In this video, we're going to complete our ANOVA table, and we need to calculate two more terms down here, which is the total variation. And I'm just going to add that right here in this cell. And so the total variance is the overall variance, and this can simply be calculated by adding up all the other three sources of variation. So I'm going to hit 0, and that's our total source of variation. And if I pull this over, and we just do this for the degree of freedom, and we have a total degree of freedom of 49. Now the next step here is to calculate two different F values from the data. So I'm just going to scroll over here to the right, and here we have our F value, which evaluates the source of variation with respect to time versus our random variation. And this will answer our research question as to whether there is a statistically significant difference across the time points. What this F value does here is this will evaluate if there is a significant difference among the participants. Now this is not central to our research question with the one-way repeated measures ANOVA, but if we wanted to conduct a different analysis called an intra-class correlation analysis for reliability, we would need this term right here. But we're going to calculate this term as well, but we'll focus on the F value as a function of time here. So the first one I'm going to calculate here is the participant F value, and I'm going to hit equal, and that's the mean square for the participant, the variation due to the participants, divided by the random variation, which is the error term. And we see we have a pretty high F value. So we're not going to worry about this one here, but this next one is going to be central to our research question. And that's the mean square across the time points. And so the question here is, do the outcome measures vary as a function of time? And so we need to take that value and divide it by the random variation in the data, which is the error term. And we got a pretty high F value at 18.36, and we need to compare this with the critical F value. And so we're going to ask Excel to look that value up for us. And to do that, I hit the equal sign, and I type in the Excel command f.inv.rt. Make that a V, not a C, RT. I shift 9, and I type in the probability of committing a type 1 error value, or our alpha level, and that's 0.05, comma, the degree of freedom between, and that would be for the time. That's what we're looking for here. We're looking for the time, comma, our degree of freedom for our error term, and that's 36. I shift 0, I hit enter, and we have a critical value of 2.63. Now what we see here is that our actual F value from the data far exceeds that from the critical value, and when that happens, we reject the null hypothesis that there's no differences across the time points. So this tells us that across all the time points there's going to be a statistically significant difference. And the p-value is the actual type 1 error rate. Recall that we had preset the alpha level at 0.05, and that will correspond to an F value of 2.63, but our actual F value is much larger. So to calculate the actual p-value, or rather to ask Excel to do that, I'm going to type in the equal sign, and I'm going to type in the command FDIST for F distribution. I shift 9, and I put in the actual F value for the data. And then I hit comma, and I have to put in the degrees of freedom for the between factor, which is this case of 4. I could have typed in the number 4. In this case, I'm just typing the cell that has a number 4. Comma, the degree of freedom for the error term. I shift 0 and I hit enter. Now we have a very, very small p-value. So this is 2.66 times 10 raised to the power of -8. So it's 2.66 with a decimal place moved 8 times to the left. So we see that the risk of committing a type 1 error, in that we reject the null hypothesis when it should be accepted, that risk is very, very small compared to the risk of 0.05, which was our initial standard. So this ends this video on constructing a ANOVA table from our calculations.